All right, here we are, question 1. For any two sets A and B, simplify A complement intersection A complement intersection B complement complement. Now, as usual, please, when you are simplifying this, first distribute the complement that is outside everything. Okay, so I'm going to get this complement which is outside everything and then distribute with the inside. So I'm going to have A complement with another complement. Remember, according to De Morgan's law, the sign here is going to change to union. Then we're going to have A complement intersection B. We have got a complement outside and then another complement that is going to come from the outside. A complement is A union A complement intersection B. We know a complement you still they'll cancel out, right? So we have A union A complement union B. Just from here, if you please, when you are simplifying, never let one letter appear twice. Never let that happen. One letter should not appear twice. So one thing I can do here, of course, that will not change anything, is I can say, let me distribute A union to what is inside. So A union, I'll distribute to that, so that will be A union A complement. And then I get the sign on the middle, that is the intersection. And then I distribute again the A union with the B, that will be A union B. Now we know A union A complement. What is A union A complement? Who can answer us that one? What is A union A complement? Mm. It's going to be what? I'm waiting. It's going to be what? So I thought we know this. This is what makes like people fail. So A union A complement is a universal set, and then intersection A union B. When you get A, you combine it with what is outside A, you are going to get the universal set. You are getting what is inside plus what is outside, you combine them, you are going to get the universal set. If it is A intersection A complement, that now is going to give you an empty set. You don't have the intersection of what is inside A with what is outside A. So A intersection A complement is an empty set. They can't intersect. What is inside can't intersect with what is outside. But A union A complement is going to be the universal set because basically you are combining what is inside together with everything outside. And any set intersection the union set. Okay, in other words, where does any set meet the union set? It is that same set. So any set intersection the union set is that same set. But any set union the union set, so if it was A union B, now union set, this would have been a union. Okay, whenever you combine a small set with a very big set, you are going to get a big set. So the universal set, okay, union any other set, it will always give you the universal set. But the universal set intersection any other set, it will be that same set. An intersection is where two sets are meeting, so always get a small set. You know that a universal set is always bigger than any set. So that's why when you're intersecting any set with the universal set, it would be that same set. But union means combining. If you combine something small with something big, you always get a big one. So every time you take the union of any set with the universal set, it will always be that same universal set. Okay, question B. Given A we have got 0 and 5, B we have got from negative 2 to positive 2, C we have got from negative 3 to positive 2. Now I want to find A intersection B. So the first thing that I'm going to do is I'm going to write the set A. So here is a number line. The set A we have got 0 and 5. Now, if you look at the brackets, this doesn't represent elements. I mean range. These are elements. So at 0, I'm going to put a dot. At 5, I'm also going to put a dot. This represents the set A. This is set A. This is also set A. You should never join these two. Don't draw any line. These are curly brackets. They mean elements. It's not a range. And then for B, now it's from coming from negative 2 to positive 2. This is a range and we're including both. Okay, we are including negative 2. We are also including positive 2. This is the set B. Now we want where these two sets are intersecting. So in other words, we want what is common between the set A and the set B. And we can see the set A only has the elements 0 and 5. And we can see 0 is also in the set B. So that is the intersection. The only thing that is intersecting between the set A and the set B is the 0. And I'm going to put that in the curly brackets. Never put them in a range. When you're writing an element, never use interval brackets. Is this okay? Okay. Bupe, is this clear? Now we want to talk about A complement intersection B. A complement intersection B. Remember, for this set, we've not been told what the universal set is going to be. Now, A complement, if we go to the set A, I'm going to get the elements in A. We have got 0 and 5. It's only 0 and 5. That means what is going to be outside A is everything, okay, apart from 0 and 5. So we're going to put like this. It will go in this direction. It will go in this direction, including between 0 and 5. You can see the set only has 0 and 5, meaning that any other elements apart from 0 and 5 is going to be outside. That is why I've just put open circles at 0 and 5, meaning that we are not including 0 and 5 in the complement because they're already in the set A. Now we want where this set intersects with the set B, and we know the set B is starting from negative 2 up to positive 2. Okay, where this is intersecting, we can see all this is common, all these things here, all these elements are all common, but 0 is not. 0 is not going to be part of the intersection. Why is it not part of the intersection? Because it is not in A complement, but we want the intersection of A complement with B. So it will be everything here, okay, except 0. If it was union, we would have taken this set. Remember, when you're talking about union, you always get the bigger set. So we would have taken all the elements from negative 2 to, we would have taken all the elements like from negative infinity, okay, up to 5, then from 5 up to infinity. That would have been the union. But intersection, what is common? So we can see that is from negative 2. Now negative 2 is here, negative 2 is also here. So I'm going to put a close interval bracket, comma. Now we're going to end at 0 because 0 is not part of the set A complement. It will not be part of the intersection. I'll put union and then we'll continue again from 0 up to 2. All those are part of the intersection. You can see 2 is in the set B, 2 is also in the set A complement, so that will be open at this point like that. So that's the set A complement intersection B. Are we all right? Is there any question? Is there any question? Okay, and then we have got the set B union C. So to find B union C, I'll first get the set B starting from negative 2 up to positive 2. We are including both. And then we go to the set C, starting from negative 3 up to positive 2, but we are not including any. So the union means combining. So you are going to start from the very smallest here. You are going to combine everything. You are going to combine everything. Okay? You're going to combine everything, even up to 2 there. So meaning that B union C is going to be from negative 3 up to positive 2. Now since negative 3 is not here, it will be open. And then negative 3, I mean positive 2, is in B, but it is not in C. When you're talking about union means combine. So if you combine something plus nothing, it will be something. So you are going to get a closed inter bracket because it is what? Union, meaning you combine. So here I've got at least something in B, though in C there's nothing. So you're going to have something, that is why I'm closing. But if it was intersection, we wouldn't have put a close. We're going to put open. Why? Because the 2 is not in this other set. Is this clear? Are we together? Okay, express 2i divided by 1 minus I squared in the form a plus ib. So first thing first, what is in the denominator, we are going to express it in the form a plus ib. Now what are we going to do? We're going to write this one 2 times and then we start crossing and multiplying. And that will just be the same as you get a first number, you square it, that will just be 1. You get the power 2, you multiply by the first number 1, you multiply by the second term, which is negative I, so that will be negative 2i. And then get the second term again, square it, so that will be positive I squared. Now you know that positive I squared is what? Is a negative 1, right? So this is going to be 2i divided by 1 minus 2i minus 1. This minus 1 and this one, they'll cancel out. So all we remain with is 2i divided by negative 2i. This I will cancel with that I. The negative 2 can go into positive 2, that will be negative 1. So this is it. We have expressed in the form a plus ib. The meaning is that you have got 0 I. Okay, you don't have any imaginary part, that's why you can't see it. So that's why it is just negative 1. Part 2, express 2.13 repeat in the form P over Q, where P and Q are integers and Q cannot be equal to 0. So the denominator is never equal to 0. So first thing first, we're going to let x be equal to what we've been given, that is 2.13. I read it wrongly. 2.13. Okay, this is going to be our equation 1. Now always make sure that the decimal point is in front of the number that is repeating. Now for this question, we can already see that the decimal point is in front of the number that is repeating. Okay, so which number is repeating? That is the 1 3. So the decimal point is already in front, so we don't need to worry. The next thing is we're going to make sure that the decimal point goes behind the number that is repeating, and that is the 1 3. So we're supposed to move the decimal point 2 times so that it goes behind the 3. So to do that, we are going to multiply equation 1 by 100. Why? Because we want the decimal point to move twice to go behind. So that will be x times 100, 100x. Then 2.13 times 100, that will be 213.13. And put a dash on top. This is going to be equation 2. Okay, from here now we need to subtract the two equations. So we're going to subtract, this is going to be equation 2 minus equation 1. So I'll write equation 2, that is 100x, which is equal to 213.13. Equation 1, x, which is equal to 2.13. Now subtract this 200x minus x, which is a 99x. Now this 1 3 at the end will cancel with the 1 3 at the end of the decimal. So all that remains is 213 minus 2. That is going to be 211. To remain with x, divide both sides by 99. That will be 211 over 99. So that is it. Are we together? Whoop, are we okay? Let f of x be equal to 3x squared minus p minus 4x minus 2p plus 1. If alpha and beta are roots of f of x is equal to 0. If f of x is equal to 0 means that write this equation becomes 3x squared minus, the way it is a function, but you write it now as an equation, okay, minus 2p plus 1 like that. That means that where there is f of x, we are going to put 0. So this is going to be equal to 0. That's the meaning. If alpha and beta are roots of f of x is equal to 0, find the equation whose roots are alpha plus 2 and beta plus 2. Now, the first thing first is when you've been given an equation which has got roots, this equation which I've written on top here has got roots alpha and beta. So the first thing we're going to do is we're going to find the sum of the two roots which we have alpha and beta. So I'm going to say what is alpha plus beta? And we should know alpha plus beta is given by what? How do you find alpha plus beta? It is equal to what? So we need to find alpha plus beta and alpha times beta. Yeah, yes, Bope.
Alpha plus beta is equal to negative b, negative b over a.
Good. That's negative b over a. So this is going to be, if we look at this is going to be our a, this is going to be our b, this is going to be our c. So you can see that b, okay, we in the formula we've got a negative, right? But this b also has got a negative already. So those two negatives are going to cancel. What we're going to remain with is just a p minus 4, positive. And then over the a, we can see that is a 3. And then we also need to find alpha times beta. How do we find alpha times beta? How do we find alpha times beta?
Is it x over a?
Okay. Hope I wanted to say something. So alpha times beta is C over A. Alpha plus beta is negative B over A. So again, we're going to go, what is our C? We can see the C is this one. There's a negative in front, and then we have got 2p plus 1 over A is 3. Please never forget this negative in front here that you have. Can never forget that. Okay, so I can just distribute the negative to the inside. So that will be negative times 2p, that will be negative 2p. Negative times 1, that will be negative 1 over 3. Now that we have this, we go to we've been given again two roots. Now they've asked us to find the sum of those two. I mean, the equation having these two roots. If you have got the roots, alpha plus 2 and beta plus 2, what is going to be the equation? Now, first thing first, you need also to find the sum of the roots that you've been given, okay? So I'm going to say sum of the roots that we have. The first root is alpha plus 2. We are going to add the second root, which is beta plus 2. And what we are going to have, we're going to put the alpha and the beta together. That is going to be alpha plus beta. 2 plus 2, that is going to be a 4. Now we are going to substitute where there is alpha plus beta. What is alpha plus beta? We have found p minus 4 divided by 3. And then we're supposed to add the 4 here, okay, which is this 4. Now we need to merge this fraction. We need to merge this fraction. I'll say this is over 1. To merge it, I'll multiply what is on top of the first fraction with what is down the second fraction. So that is going to give us p minus 4. And then I multiply the 3 down the first fraction with the 4 up the second fraction. That is going to give us a 12. And then in the denominator, multiply the 3 and the 1, that will be 3. So this is going to give us, so I'm going to write on top here, sum, we can see is giving us p. Negative 4 plus 12 is what? Is it a positive 8? And then in the denominator, we have got a positive 3. So this is the sum of the two roots. And then the next thing that we need to find is the same two roots that you've been given, we find their product. It doesn't matter the roots that you've been given, you always need to follow this as long as they've asked you to find the equation. Okay, we're now going to find the product. So the product is going to be given by the first root, that is alpha plus 2, multiply with the second root, which is beta plus 2. So if you do the multiplication, you're going to get alpha beta plus alpha plus beta, then plus, not plus alpha plus, this is going to be, if you multiply this alpha times beta, that will be alpha beta, this alpha times 2, that will be 2 alpha, then 2 times beta, that is going to be 2 beta, and then 2 times 2, that is going to be a 4. And then from here, I can also write this as alpha beta. I'll factorize out a 2. We are going to remain with alpha plus beta, and then at the end, we have got a positive 4. And then we'll substitute where there is alpha beta. We know alpha beta is this. Okay, I'm going to put negative 2p minus 1 divided by 3, and then plus 2. Where there is alpha plus beta, I'm going to put this, which is a p minus 4 divided by 3, and then at the end we have got a plus 4. We also need to make sure that we simplify this and merge as a single fraction. Alright, so I can write this as we have got negative 2p. Please don't write the this fraction the way it is. Don't extend the line to any place. I have seen a lot of times when people are answering questions with fractions, you end up writing the fraction, it reaches at the very far end. The fraction, make sure that you know where it starts and where it ends. Otherwise, if you change, you've changed everything. You're going to get it wrong. Okay? This fraction just ends up to there. And then I'll multiply 2 times the p on top, that is going to be 2p. 2 times the 4, that will be 8. And then also here, the fraction just ends here. And then you write the 3 in the denominator. Don't extend the fraction to the 4. The 4 is just alone. Okay, the 4 is just alone. So I'm going to say, I can write this as negative 2p minus 1 over 3, and then plus 2p minus 8 over 3. Now this is a 4. Since everything is over 3, how can I make how can I make it to have the 3 in the denominator? We know that 4 is the same as 4 over 1, right? So I want also to have the 3 in the denominator so that it will be easy to add. So I'm going to multiply on top by 3. I'm also going to multiply down by 3. Okay? So down 4 times the 3, that is going to give us a 12. I mean on top. And then down 1 times 3, that is going to now give us a 3. We can see now that the 3 is common for everything. I'll just put 3 as a common denominator. And then I'm going to add what is on top. So I've got negative 2p minus 1 plus 2p minus 8, and then plus a 12. So add like terms. Negative 2p, positive 2p, these are going to cancel out. And then I've got negative 1 minus 8, that's negative 9. Negative 9 plus 12, what are we going to get? Is it a positive 3? Okay, we're going to have positive 3 over positive 3. We are seeing this is going to give us what? A 1. So I'm going to write here, we've seen that the product has given us a 1. If you did wrong things, you don't find the 1 here. For example, if you extended the, the fraction to where it was not supposed to be, you would have not found the 1. So please make sure that you do what is right. Okay. Now, when you are finding an equation is given in this general form: x squared minus sum multiplied by x plus product is equal to 0. Okay, this is a general form of an equation. So you are going to write x squared minus, please you need to know this general form, minus the sum of the roots that we have found is what? P plus 8 divided by 3, and then you put an x, and then plus product of the roots, that is a 1, and that will be equal to 0. So this is the equation we have found. Okay, that is the equation. If you want to simplify it yourself, you can now say, okay, since I can see a 3 in the denominator here, I'm going to multiply the whole equation by a 3, just to remove that 3 in the denominator. So 3 times x squared, that will be 3x squared. If I multiply the 3 with this 3 in the denominator, it will cancel, so just remain with negative p plus 8x. And then this 3 times the 1, that is going to give us positive 3, and that is going to be equal to 0. Or you can leave it here, it is also fine. Are we okay? Are we good?
Personally, I'm kind of confused, but I'll just watch the video. And you can see.
Please don't allow that. If you are behind somewhere, just at that very point when you are behind, just be free to ask, because you might go on and rewatch the video and still not get it, so it will be a bit tricky. At the very moment when something is not okay, be sure to ask. We are not rushing for anything. All right. Prove the following trigonometric identities. First one, cosec theta plus tan theta sec theta is equal to cosec theta sec squared theta. Now, you need to look for the side that is a bit complex, that you think you are able to show. Which one do you think? Which side should we use? Is it the left hand side or the right hand side? So this one is the left hand side. This is the right hand side. So which one should we prove? Which one looks a bit complex? Which one do you think we should prove?
The left hand side.
All right, the left hand side, at least because we have got a plus that is, of course we can prove any side, but just go for something that is a bit more common. So we use the left hand side, and that is equal to, now a cosec. I'm going to convert a cosec. Cosec is a reciprocal for what trig ratio? Vupe, cosec is a reciprocal for what trig ratio?
The effect of time.
Yes. So cosec looks like sin, like cos. Just know that it is not the opposite for cos, it is the opposite for sine. Right? So that will be 1 over sine theta. And then we have got plus tan. We know that tan is sin theta divided by cos theta. Okay? Multiplied by, we have got sec. We know that sec looks like sin, but it should be the opposite for cos. So it is 1 over cos theta. And this is going to give us 1 over sin theta plus, on top, sin theta times 1, that is still sin theta, down cos theta times cos theta, that is cos squared theta. We now made this as a single fraction. What is on top of the first fraction? A 1 multiply with what is down the second fraction, a cos squared. We're going to have cos squared theta. What is down the first fraction multiply with what is on top the second fraction, that gives you sin squared theta. And then over multiply the two denominators, that is sin theta cos squared theta. Now on top, what is cos squared theta plus sin squared theta?
One.
Okay,
One.
that is a 1. And then in the denominator we have got sin theta cos squared theta. Now at this point, remember where we are going. I'm going to split this, okay? Since they are multiplying, in the denominator, I can write it as 1 over sin theta multiplied by 1 over cos squared theta. There's nothing that has changed. Okay. Now 1 over sin, we know that is what? A cosec. And then 1 over cos, we know that is a sec. But remember, it's not just cos, but cos squared, so it will be sec squared. Hence proven, or hence shown. We are okay? Are we good?
Yes.
Okay, so for the second identity, which one do you think we should prove? Is it the left hand side or the right hand side? Which one should we prove?
Mm, for me, I think we prove from the right hand side to the left hand side.
Okay, from the right hand side to the left hand side. Now, if you look at this, like if you want to prove this one being equal to this, for me, I can clearly see that it's going to be trick. Why? Like think of this. How are you able to simplify one minus cos? Maybe you have got an idea. We can work with it. What can we do from here? Like what route should we take? Or what is coming in your mind? The first thing that you're able to do, anything that you can do from here. Bope, do you have
No,
any?
no, it's not making sense. I've seen where where might be made.
Yeah. So would rather use the left hand side. Of course, I could have multiplied on top by sin, even down by sin, or anything like that, but to just complicate things. So use the left hand side, that is 1 divided by, we have got cosec. Now, cosec theta, we know that is 1 over sin theta. Okay? And then plus cot. What is cot theta? What is cot theta?
Mm, I think cos over sine.
Yes, it is just the opposite for tan, so it is cos theta over sine theta. Now we are going to merge what is in the denominator as a single fraction. You can see they have got a common denominator, 1 over sin, cos over sin. So just write a sin, I mean, in the denominator because it's common. And then we just add what is on top, right? We add what is on top, 1 plus cos theta. Okay, and then we can as well write this as 1. Instead of writing over, I'm going to write divided by 1 plus cos theta divided by sin theta. And then I'm going to change this division into multiplication. Becomes 1 times sin theta over 1 plus cos theta, right? Like that. Okay. Now when we reach here, of course, when we multiply, we are going to get sin theta divided by 1 plus cos theta. But is this where we want to go? This is not where we want to go, right? And it is going to again trigger your thinking. Like, okay, think of it. How can you move from sin theta over 1 plus cos theta going to 1 minus cos theta over sin theta? What do you think? What can you do? So I've got sin theta divided by 1 plus cos theta. So the only thing that I'm thinking of that has come to my mind is I'm thinking of, okay, I can multiply on top by sin theta. Down also I'll multiply by a sin theta. Okay. So that is going to give us sin theta times sin theta, that is a sin squared theta. And then down we are going to have 1 plus cos theta and then sin theta. Now, what I don't do you know? What is sin squared theta? Anything you know about sin squared theta? Yes.
Before bit confused. How I reached this part? I think I was a bit behind.
Now I don't know where to start from. Which stage are
You
you?
have to start.
Which stage are you behind on?
After I had to split,
Okay, you can tell me
that's
where.
what I
you-
did.
After I had to split what?
I think the first part when you wrote 1 over the second split and then plus 2 cos.
Okay, follow up, please. Please ask when we've not gone too much far. Like it will take us too much behind. Okay.
Because you said changing, so I got a bit mixed up.
So we have got the left hand side where we've got 1 divided by the cosec here. I'm going to write it as 1 over sin theta. The cot, I'm going to write it as cos theta over sin theta. And then we are saying we're going to make the denominator as a single fraction. Okay. Since these two are the same, I'll just add what is on top. That will be 1 plus cos theta divided by sin theta. Is that okay? Is this addition okay, or I should do the one for multiplying this and then multiplying this? Which one is better for you?
It's okay. It's okay.
Okay. Now from here we said we can also write this as 1. Okay, this one on top. Now this over I'm going to write as divided by. Then we're going to have 1 plus cos theta divided by sin theta. If I change this into multiplication, we're only going to have sin theta on top, and then down we're going to have 1 plus cos theta. Is this okay here?
Yes,
Now it is at this point that I'm saying, you've seen where we are going. We are going to 1 minus cos theta over sin theta, but we have got sin theta over 1 plus cos theta. This should tell you that 1 minus cos theta over sin theta is the same as sin theta over 1 plus cos theta. But we've not shown. So I'm going to multiply on top by sin theta. Even down, I multiply by sin theta. So what we're going to have on top is sin squared theta. And then down we are going to have 1 plus cos theta and then sin theta. We are good?
yes.
So it is from here that I asked, what identity do you know that we're able to substitute on sin squared theta? Do you know of any identity?
1 minus cos squared theta.
So we're going to put 1 minus cos squared theta and then divided by 1 plus cos theta and then sin theta. I think Bupe can answer this. What do you think of this? What are we going to do?
I think on top it's going to be like a difference of two, two squares.
That's the thing.
That's what it is.
1 minus cos squared theta is a difference of two squares. So I can write it as 1 minus cos theta and then 1 plus cos theta. Okay. And then down you have got 1 plus cos theta and then sin theta. So you can easily see that this will cancel with this. And what you're going to have is 1 minus cos theta divided by sin theta. Hence shown. Are we okay?
Yes.
All right. And then question B, find the general solution of 2 sin squared theta plus cos theta minus 1 is equal to 0. Now, I've been mentioning this. You can't solve an equation where you've got c and you've got cos and a constant term. You need to express them in the same ratio. What do you think we're going to do? What do you think is going to happen? Let's go on. So where there is sin squared theta, we are going to replace. So this is going to be 2. Where there was sin squared, we're going to put 1 minus cos squared theta. And then we have got cos theta. And then plus a 1, and that will be equal to 0. So we'll now multiply 2 times 1, that is going to be 2. 2 times the cos squared, that is going to be 2 cos squared theta. And then plus cos theta plus 1. Yes? Alright. Is this okay? Are we okay at this stage?
Yes.
Alright. And then we can add like terms. This 2 plus 1, that is going to give us a 3. So we're going to have negative 2 cos squared theta plus cos theta plus 3 being equal to 0. So what we have here is a quadratic equation. So I'm going to find the product. The product is going to be negative 2 times 3, which is negative 6. And then the sum, which is a positive 1, write a number in front of cos. So what two numbers can we multiply to get negative 6? We add them, we get 1. Do you know of any?
Uh,
Yes, Frida?
negative 2
Mhm.
and positive 3.
Yes, so we're going to use negative 2 and positive 3. So this is going to be negative 2 cos squared theta, and then negative 2 cos theta, and then positive 3 cos theta, and then we write the 3, that is equal to 0. So we're going to factorize out negative 2 cos on the first 2. What remain here is only a cos because it was cos squared, and then it will become plus since I've removed the negative 2. What remain here is just a 1. And then for the second 2, I'm going to factorize out a 3. What remain is cos theta plus 1. That will be equal to 0. So pair what is outside, that is going to be negative 2 cos theta plus a 3. And then we have got cos theta plus 1, that is going to be equal to 0. So I'm going to equate both to 0. I'm going to equate this to 0. Then the 3 will go the other side, becomes negative. And then we'll divide both sides by negative 2. So it will give us cos theta being equal to positive 3 over 2. Okay. And then I'm going to get the 1, take it the other side. So I'm going to have cos theta being equal to negative 1. So these are the two equations that we are supposed to solve. All right. So what are we going to do to solve this? So we're going to say theta is equal to cosine inverse of 3 over 2. Now, the 3 over 2, mostly it was supposed to be a special angle. In our case, because this time around there's no calculator, this was supposed to be a special angle. Okay, but here you don't, this is not a special angle. Cosine 3 over 2, that's not a special angle. So Just this paper should use a calculator to find that. So punch cosine inverse of 3 over 2. Okay, just give me a moment. Please, if you've got a calculator, you can help me punch that. So cosine inverse of 3 over 2 is giving me 55.14 degrees. Now, which other quadrant is cos positive? Which other quadrant is cos positive? Okay, please just give me a moment. Just a moment, my network. Okay, can you see now?
Yes.
All right. So I was saying you punch cosine inverse of 3 over 2. That is going to give us about 55.14. Okay, 55.14. That is going to be the value. Now from there, I'm asking that in which other quadrant is cos positive?
The fourth quadrant.
Fourth quadrant. So to find the angle there in the fourth quadrant, another theta, what we are going to do is, in the fourth quadrant, you always subtract from 360 the answer that you have found, okay, in the first quadrant. So that will be 360 minus 55.14. So what have you found if you have got a calculator? It seems I don't know what's happening with my calculator here. Okay, please give me a moment. 360 minus 55.14. So that is about 304.86. 304.86. Okay, these are the two values from the first equation. Now, if you look at the second equation, it is equal to a negative number. So to find the solutions, I don't want to deal with anything negative. So what I'm going to do is I'll make the one positive. So I'll say, okay, let the cos, instead of theta, I'm going to say alpha being equal to positive 1. And then now I find the alpha. Alpha is going to be cosine inverse of 1. Okay, cosine inverse of 1. Now, 1 is a special angle. You just look at cos, okay? Like cos starts on top here at 1 and then it goes like this. So you can see for cos to be 1, it needs to be 0 degrees here. So that means that alpha is going to be 0. Like the degrees, you get them on this axis. So that means if y is 1, you are going to get theta 0. It means that the other solution is going to be here, which is the 360. Because we know, okay, so since we have found 0, that is alpha, but we are not interested in alpha, we're interested in what? In x. So we're going to go to x. Remember the one was negative. So ask yourself, in which quadrants is cos negative? In which quadrants is cos negative?
Second and third.
Second and third. So in the second quadrant, how do you find angles? It is always, how do you find angles in the second quadrant? Always the angle that you have found in the first quadrant, okay? The angle that you have found in the first quadrant, remove it from 180. It is 180 minus the angle in the first quadrant. That is how you find angles in the second quadrant. that is going to still be 180. And then in the third quadrant, you always add 180 plus the angle that you have found. Now we found 0. So that will still be 180. In other words, it's only 180. Okay? So cos theta can only be -1 if the angle is 180. If you're talking about angles between 0 and 360. Now remember, for this question, they've not asked us just to solve, but to find the general solution. So after you do this, you have found the solutions. Now you need to determine the general solution. So I'm going to come on the quadrants there. So the first angle that we found, the first angle we found was 55. That is going to be somewhere here. Okay, that is the first angle, 55.14. The next angle that we found was 304. That is obviously in the fourth quadrant. It's somewhere here. You need to know that this 55 is the same as this angle which is below, this angle below here. So the angle that we've determined now is this one, which is the 3004.86. Then the other angle that you have found is 180, and 180 is here. Okay. So these are the solutions that we have found. Now to write a general solution, let me have some space. All right, now to write the general solution, you are looking at now each of these angles. Like for this line here, if you move around, like you make a 10, okay, you make a 10. How many degrees of you should you move for you to move from this point and coming back to that point again? That's a question. You want all the angles that you get when you come back to this point. Yeah? How many degrees should you turn to move from this point back to this same point? Have we gotten what I'm asking? So that means for me to move from 55.14 degrees to come back to it, I need to add 360. So the general solution is going to be 55.14 plus 360. Okay. Now to 360, I'm going to put n, meaning that it doesn't matter how many number of times we are going to turn. I might make the first revolution, I'll come back here. Second revolution, I'll still come back here. Third revolution, I'll come back there. That is a general solution. Okay, it doesn't matter how many revolutions I take, I'll still arrive at that same point. But we also have this angle. We also have this one. Okay. Now for us to reach to this angle which is here, what is going to be happening? If I am here at 3, this is 304.86. The only way I can come back to that point is if I add 360. Okay? Like if I'm here, I add 360, I'll come back there, 360, I'll come back there, 360. So I'm going to put also n, right? N. The other angle that we have found is 180. 180. Now, how can I come back to 180? So if I'm here, I need also to add 360, 360. So that will be 360 n. So this is going to be the general solution. These values that you have found are solutions, but this is going to be the general solution. Are we okay? Are we together?
Yes.
Elizabeth, are we okay?
Yes.
All right. So we have got another question here. Given that f of x is equal to sine 2x plus pi, where 0 is less than or equal to x, which is less than or equal to 2 pi. State the amplitude. Now the question is state, so there's nothing to solve here really. So the amplitude is given by the absolute value of the number in front of the sign. We can say the number in front of the sign is what? What is the number in front of sign here? 1. So that is basically the amplitude. So if it was negative, you find its absolute value still give you a positive value. And then the next one, we want to find the period. Period is given by 2 pi divided by the number in front of x. Okay, divide by the number in front of x, which is 2. And that the period here is pi. And then phase shift of y is equal. So in other words, phase shift of the function. Now, when you're talking about phase shift, to just get this function, you equate it, you get whatsoever is inside the brackets, they equate to 0. So 2x plus pi is equal to 0, meaning that x is going to be, take the pi the other side, negative pi, and then divide both sides by 2. That will be negative pi over 2. That is a phase shift. The next question is asking us to hence sketch the graph. Hence sketch the graph. So sketching a graph is the most interesting thing to you do on this. So what I'm going to do, I'll use this same line which has been given to me. I use it like this. I'm just going to put a line somewhere here. Okay, like that. Like that. This is going to be the y. This is going to be the x. Now the first thing that I'm going to put is a vertical shift. Now, if you look at this function, it doesn't have any vertical shift. Like we don't have any constant that we've added to the function. I mean that the function is going to be alternating just per 0. All right, there, that will be the symmetric point. And then I'm going to put a phase shift that is negative pi over 2. So I'm going to put somewhere here negative pi over 2. Okay, that means somewhere here is supposed to be positive pi over 2. Okay. Now, the next thing that I'm going to do, yes, Elizabeth.
So how do you come up with a scale? Do you just come up with the scale is scale? I'm just confusing
Okay, so for you to come up with a scale, you are going to look at the first thing is I'll just put down the phase shift. So the phase shift, you just have to put it there. Okay, you just have to put it there, and then what will determine the scale is your period and your phase shift. So look at the period. Like the period will tell you the duration. For example, my journey is taking 3 hours. The phase shift is telling you I'm starting at 12 hours. So I'm starting at 12 hours, my journey takes 3 hours. What time I'm going to reach? What time am I going to reach? So that will tell you what time you're going to reach. Okay. So what you do is, how do you find the time you're going to reach? You know that your journey is taking 3 hours, but you're starting at 12 hours. You are going to add. So even here, your journey is taking pi, but you are starting at negative pi over 2. How do you determine where you're going to reach? You add. So add negative pi over 2 plus pi. And this is just going to give you positive pi over 2. Okay? Meaning that for you to complete a complete revolution, you are going to move from negative pi over 2 to positive pi over 2. This is a complete revolution. This is what you need to know. Because it is like this, I'm going to even make this one. I'm going to move it a bit. So this is going to be negative pi over 2. And then up to positive pi over 2 is supposed to be equal, okay, to positive pi over 2 there. Before I go any further, is this okay? Is this okay?
Yes.
Okay. The other thing that I need to put on my function is the amplitude. Where will be the function alternating? Okay. So this function is going to be alternating between positive 1 and the negative 1. How did I tell that? The amplitude d is 1 and the function is starting, like the symmetric point of the function is at y is equal to 0. So that means that a complete revolution is going to be between negative pi over 2 and positive pi over 2. And then what remains is I'm going to divide in two halves. Negative pi over 2 plus pi over 2, that will give us 0. 0 over 2 is still 0. In other words, what is the midpoint of negative pi over 2 and pi over 2? That is a 0. So I need to put a point here. Okay. And then I'm going to look at the midpoint also for between negative pi over 2 and 0. What is the midpoint? Between negative pi over 2 and 0. What's the midpoint? Who can answer us? So all you do is get the same negative pi over 2, get the same other point which is a 0, add them. That will still give you negative pi over 2. And then divide by 2 because we're looking for the midpoint. That will give you negative pi over 4. Okay, negative pi over 4. Now, because the amplitude, the number in front of sin is positive, the function will start going first up. So at this midpoint here, the function is supposed to go up. And then also get this 0 again with this positive pi over 2. Add them and divide by 2. That will give you positive pi over 4. This is where it will come to the minimum. That means the function is going to be alternating between just these points. So how is it going to move? It will first move up. It's supposed to come and pass through the center, go to the minimum, and then come back like this. So that is how the function gets to move. Okay? But okay, first before I say anything, is this okay?
Yes.
Now remember, if you draw this, they will not give you all the marks. Your function is supposed to alternate between 0 and 2 pi. It should be between 0 and 2 pi. Okay? So what I'm going to do is I'm going to continue increasing the function going forward. So let me even remove this. Okay, the function is supposed to be going more forward and more forward like that. Now it's not going to fit if I put this space. The distance is supposed to be equal. So if you see I've divided this graph into four quarters, that means each quarter is 1 over 4, right? 1 over 4. For me to move from pi over 4 to pi over 2, I add pi over 4. Like this pi over 4 plus pi over 4, it gives me pi over 2. If I want to go to the next quarter, I have to add another pi over 4. So that is pi over 2 plus pi over 4. That is going to give us what? That is 3 pi over 4. So that is where the function is going to go. 3 pi over 4. Again, 3 pi over 4 plus another pi over 4. Okay, that is going to give us pi. And then from pi now, it will not even fit. So you are seeing that if you have got like you have got a number here, a number there is a number on the middle, you are going to make a half wave. So that means we have got a number here, we've got a number here, and the number on the middle are going to make a half wave. It is going to go like that. And then this very point is going to be the maximum. And then you are going to also add pi plus pi over 4, you add again. So the function will still come again like that, but there's no space, and then it will go back. So I need to reach at 2 pi. Are we able to do that? Are we able to do that? Or I should show it? Let's hurry. Can we do that or I should show it? Are you able to get me or not?
I wanted to do.
Let me just show it so that not have anything to point to that we didn't do it. So I'm going to put the line here. Okay. Please, the easiest thing to do is this. Please, the easiest thing to do is this. First, get your phase shift. That's negative pi over 2, right? I'm going to put it. My phase shift is negative pi over 2. Look at your period. Please look at your period. You need to add the phase shift and the period. That is pi plus negative pi over 2. That is going to give you positive pi over 2. Okay, meaning that this is where you are going to end. So I'm also going to put that pi over 2. This means that between negative pi over 2 and positive pi over 2, I am supposed to have a complete revolution. I'm supposed to have a what? A complete revolution. Okay. Now, I'm going to divide this region into 4 equal halves. What do you do? Get the first one, negative pi over 2, add the last one, positive pi over 2. What? The answer you get divided by 2. Now we know we're going to get 0. 0 divided by 2 is still 0. So that will be a point here. Okay. And then again, what I'm going to do is add this point 0 plus this point and then divide by 2. So negative pi over 2 plus 0 is still negative pi over 2. Divided by 2, that is negative pi over 4. And then also 0 plus pi over 2 and then divided by 2 is still be positive pi over 4. Okay. Now using just any 2 points which are close to each other, just find the difference between each. These are 4 equal quarters, like they are 4 equal quarters. So what I would do is I'll just get this. I'm moving from 0 up to pi over 4. What do you think is the duration? So what I'm going to do is the final position minus initial position. So I'm going to pi over 4. I'm coming from 0. Okay. That will give me pi over 4. In other words, if I move from negative pi over 2 to negative pi over 4, what did I do? To just negative pi over 2, I added pi over 4 to get negative pi over 4. For me to move from negative pi over 4 to 0, I added pi over 4. To move from 0 to pi over 4, I added pi over 4. To move from pi over 4 to pi over 2, I added pi over 4. So I'm going to continue adding pi over 4 until I reach at 2 pi. Until I reach at 2 pi. Okay, so I'm going to say pi over 2 plus pi over 4. That is going to give us 3 pi over 4. Pi over 4, 3 pi over 4 plus pi over 4. That is going to give me pi. And then pi plus pi over 4. That is going to give us, this is pi plus pi over 4. What we are going to get? That is going to be 5 pi over 4. Then 5 pi over 4 plus pi over 4. That is going to give us, that should be 6 pi over 4. Okay, 6 pi over 4, which is just 3 pi over 2. We are just adding pi over 4. So that is 3 pi over 2. And then the same 3 pi over 2, which is the same as 6 pi over 4 plus pi over 4. That is going to give us 7 pi over 4. The same 7 pi over 4 plus pi over 4, that is now going to give us 2 pi. So this is where we're ending. Now remember, for each if you come from negative pi over 2 to positive pi over, negative pi over 2 to positive pi over 2, supposed to move a complete 10, right? A complete revolution. So meaning that you are first going up to 1, you come like this, and then you come to the minimum like that, and then you come here. Again, from pi over 2 to pi, you are going to move on top like that. Because one of these, one point should be the midpoint where to go to the maximum, and then you are going to come like this, okay, up to this point, and then again you're going to move up and then come here. Now you don't need to show the negative side, so it will be alternating between -1 and the +1. So the graph is going to go like this, it comes like that, it goes like that, goes like that, and then it comes like this. So this is a graph that you're supposed to do. Don't show the negative side because you are drawing between a 0 and a positive